So thank you for your kind words. And of course, I have given away the punchline here a little bit. Stop data sharing usually puts people at the front of their seats, but I've already given away that we now say we go from data sharing, where most people think I have to share my data with others by sending them physically away to another place and copy them. That's no longer needed. So the technology of today, based on FAIR data, of course, makes it possible to visit data with algorithms. In 99% of the cases, you don't have to move the data anymore. So I will go through this, and I feel that if there is really something unclear, stop me, but I will first give some background on how FAIR came about, why, and then we can talk about the Liefers Institute in the end, and how is it AgBioData or AgBioData can play a role. So, as I said, the end of data sharing is near, in the sense that if the data, the FAIR data, are indeed AI ready and fully machine readable, and they are in a FAIR data station that is visitable, then algorithms that you see depicted here as trains that are following the track and are being checked when they enter the station, whether the question is legal, whether there is no problems with consent and all these kind of things. So this is also for sensitive data. And then the algorithm asks the question, puts all the answers together, and gets the answer, the same answer that it would get if all the data were actually in the same database. So the Liefers initiative that I will talk about at the end a little bit is a new initiative that has already 30 members, but we are growing every week. And it's basically bringing people together that take FAIR seriously. I will say what that means in a minute. And we will not intervene in the applications or the infrastructure that people have. We only focus on the center of the hourglass. We connect people, we implement together, and we innovate that way. But only by doing stuff, as we call it, at the center of the hourglass, which is a bit comparable to TCP/IP in the internet. It doesn't matter what applications you build or infrastructure you use, as long as you follow the right protocols in the very center, you are part of the system. We call this the Internet of FAIR Data and Services. I will come back to it later. So how did this all start? I found out when I was still working on malaria that people couldn't match through languages in Africa and everything. So I started to do more ontology type of work. And then in 2014, we realized that the data were exploding so much that we actually organized a meeting at the Lawrence Conference, which is a prestigious conference bringing 40 people around the world together for a full week. And that's where we came up with the FAIR principles. But the funny thing is that we had this title, Jointly Designing a Data Fairport, which was just a wordplay on airport and then an F, also FAIR with small letters. But in the end, we said, okay, we came up with 15 principles, and I reshuffled them in F, A, I, and R, maybe inspired by the title, and those became the FAIR principles. The main idea that we had, we should reduce ambiguity in data, so better metadata, machine readability, and we saw already in 2014 that machines would really help people in the future more and more to make sense of huge data sets, pattern recognition, etc. Now, what happened straight away, actually within 2 years, the principles were adopted by the G7, the G20, and more funders, which sounds very nice, but it is also having a downside because it became a hype term. And now lots of people say they are doing FAIR because the funder requires it, but they don't. And Roche, one of our founders, came up with the term fake FAIR and even FAIR washing. So we felt that we have to also safeguard the original meaning of the FAIR principles. Now, one of the things that happened soon after we published this paper that you see here on the left-hand side, came out in 2016. It took us about 2 years to get everything done and peer-reviewed and everything. In the abstracts, as you see highlighted here, it already states that it is to put specific emphasis on enhancing the ability of machines to automatically find and use the data. That was the starting point of FAIR. Not just making things findable, accessible, interoperable, reusable, but for machines. And then, of course, they also become more accessible to people because you remove a lot of ambiguities because machines are stupid. So you have to be very precise what you mean. What also happened because of the hype term, a lot of people made their own interpretation. And we said, let's write another paper the year after, cloudy, increasingly fair, to come up with all the mistakes that people made when they talked about FAIR, like it's the same as open, all these kind of things. And we said, no, what they are, by design, is a set of guiding principles, not yet another standard, along which you make standards. And then we went through, they're not open, they're not a standard, they're not just for life sciences and so on, because there was a lot of misperceptions about FAIR. Then we said, okay, let's go back to the basics and explain once more what you actually mean if you want to go for fully AI-ready data, as we call them now, and have machines assisting you perfectly, not talking just LLMs and those kind of things. So if you have a concept in mind, let's take cancer for now. Cancer doesn't exist. It's a mental construct, a concept. You have individual tumors and cancer instances, but the concept cancer can be referred to by a lot of different tokens: cancer, malignant neoplasms, Krebskrankheit in German, CO265 in Unified Medical Language System, and so on. Then there is the real object or the mental construct, which is not necessarily an entity, but it has a term, has a defined meaning. And it shouldn't matter which token you use. If that token leads to the intended defined meaning, the machine knows what you mean. That is the very basics of what we tried to explain. And that's also the nano-publication basis that we started with. Everything should be a triple with provenance and time date stamp so that even stupid machines understand what you're doing and what you mean. Then we started Co-FAIR, and we said, look, there are so many interpretations of the FAIR principles. Let's make one interpretation that a growing community agrees upon, still with, a lot of freedom. But for each of the principles, we made in this article that you see here, a text that went into how do you implement this principle. And here you see, for example, a very tricky one, the one that was also almost not measurable. There are now 26 FAIR evaluators to see how fair your data are. But this one, you can hardly evaluate before, and that's just very important for your network, a recognized expert community, as we call them, has said, what is the domain relevant community standard for the metadata and the data? Because in biodiversity, you might make some different choices for a thesaurus for species or proteins than in agriculture or in health. Still, we aim for cross-domain interoperability. So rich metadata is a very important part of the FAIR principles. And we started a website on the GoFair Foundation. You can go there. And if you click on any of these principles, you now see that we say you need a globally unique and persistent identifier. In fact, we say now a resolvable identifier, GUPRI, meaning indeed that for every concept that you refer to in your data, the machine is able, and therefore also people, to resolve that identifier to the intended defined meaning. So don't put PSA somewhere, which has 189 different meanings in Medline alone. At my age, you think prostate-specific antigen. A young guy would think Peugeot Citroën or some other psoriatic arthritis. It has 189 different meanings in Medline. So we say never use a TLA, which means a three-letter acronym. Okay. Now in A1.2, it's not equal to open. In an example, I took vocabularies as the methods that unambiguously represent concepts, and we make an emphasis that a good vocabulary or thesaurus or an ontology should be fair itself. In other words, it should be machine actionable. And that's beyond machine readable. Machines should actually be able to act on it. Okay. Now the 1.3 we already saw. And then a very important thing that we also introduced in GoFair, which was later taken up by the European Open Science Cloud and by CoData, and now much wider, I'll show that, is that a community, and I would go for one straight away for your network, would make choices for every principle, but also for every ontology and metadata models. Like we use ORCID for people, we use DCAT for this, we use UniProt for proteins, the drum for digital representation of units of measure. And what we then see, if people publish that, especially also in machine readable format, you get automatic networks that show you which thesaurus is used more frequently in which domain, and you can start to drive convergence without telling people that they can only use one ontology. But for example, the simplest one that is also referring to the US versus Europe, let's say that our recommended thesauri or gene lists for genes are in NCBI in the United States and EBI in the European setting, then the FAIR implementation profile, which is machine readable, would automatically guide a bot or any person that helps you to make data fair to choose NCBI gene numbers in the US and EBI in Europe. But since they are fully mapped, there is absolutely no problem. The machine knows what you mean. So we are now publishing these implementation profiles. This is already an older slide. I'm sure there will be more if you go there now to FAIR Connect. But last time I checked, there were 602 published FIPS already. And I made some of them yellow here that are relevant for your community. So we have already for data management, life science, ecosystem, hydrology, and so on, agriculture. So here you see how many FIPS there are. When you click on them, you see which choices they made. So one of the things we could do together is to make a recommended, and we have the wordplay recognized expert community, and then recommended FAIR implementation profile, publish it in FAIR Connect, CoData endorses it globally, and then anyone who wants to make data fair to share them, or databases, share them in your community and beyond, would automatically become interoperable. So we said GoFair has this website, and our goal was to rigorous adherence to the FAIR principles, not fake FAIR or FAIR washing and put a DOI on a PDF and say you're fair, because it also gives FAIR a bad name. Some people say, oh, FAIR doesn't work. Yeah, they didn't go FAIR. Of course, we want data to be as open as possible, but we work now with patient data and all kinds of other sensitive data. A lot of the data in agriculture and biodiversity can be sensitive as well. One of our Indian partners, he publishes the snapshots that they make every day of the tigers. They will be dead the same afternoon by poaching. And we work with this hourglass architecture, only minimal standards in the center, and let anyone do what they want, which also mitigates the potential vendor or provider lock-in, and you get monopolies. So we can move away, for example, very easily from Microsoft servers now, because of the Cloud Act, which is a big thing in Europe, because people are scared that, the government in the United States can see whatever is on a Microsoft server, even if it's safe data. So the Cloud Act is a big thing in Europe at the moment. People are copying data, shielding them from any of the big vendors of the United States. We do not want to get into that fight. We stay out of that. Implementations, infrastructure, use whatever is good for you. So you see the hourglass here again. 10 years later, exactly 10 years later, in January again, we had another meeting called The Road to Fair and Equitable Science, where we really also made, with Africans, the very strong commitment to make a system and build an ecosystem, the Internet of Fair Data and Services, where data are fully AI ready. So we renamed FAIR also as fully AI ready. That's FAIR again. We had a whole day with the pharma and Africans on equitable access to data. And we emphasized for a full day again the machine actionability, because that's the most persistent misperception of FAIR. Let me say this once and for all. There is not such a thing as FAIR and not machine actionable. Doesn't exist according to our original paper. Of course, we cannot trademark the term FAIR, but if you want to follow GoFair and EOSC and the LIFES lead, you take FAIR seriously, and it yields machine actionable data. And based on this meeting, we started the Institute, or the Initiative for Fair and Equitable Science in Leiden. You see on the right-hand side the logo. You can cut off the L and have any Initiative for Fair and Equitable Science. But so far, everybody joins LIFES because it's a global association anyway. You can just become a member. Now, a few content things that are, I think, very important. I'm going to Berlin tomorrow and Lausanne next week on 2 meetings where we say LLM is not artificial intelligence. It's token prediction, it's advanced statistics, and I'm not against LLMs or any other AI type model at all, but use them for what they're worth. They're advanced parrots that just are as good as the data you feed them, and actually they have no clue what they're putting out. So everything they put out is a hallucination, but some of these hallucinations make perfect sense to us, and some are even new to us, or at least to the user, and therefore they can be very convincing. Therefore, if they make a mistake, and they do it all the time, it looks so beautiful that you fall for it, and that's a big danger. So we say fully AI-ready data means you feed any machine learning model, not just LLMs, with fair data that are very well understandable for machines. So at least you catch already one thing, that they do not make all kinds of misinterpretations on terms or whatever at the beginning. And at the outputs, the right-hand side, you have to restrain the outputs with conceptual models. If you have a conceptual model that it adds like a filter on the graph and saying, don't come out with statements like a protein can make a protein complex with a building or something like that. So things that are impossible can be easily captured early on in the models. So what we are aiming for also in LIFES is what we call hybrid intelligence. And that is what scientists and innovators are waiting for, and even doctors. The bot should continuously ask you, is this okay? I did this, I'm explainable AI. Okay? Again, that can only be done if the data are in order. No model is good unless it's fed with good data and validated on proper data. Now, one of the examples we have, I mentioned it earlier on, is this one. Actually, I could have changed this for the marine biology example that they did for the Gulf of Biscay in Spain. Imagine you have this bot, Clara. She knows everything I know about data stewardship. She read my book. She has been fed with all the ontologies that are needed. And you enter a CSV file of your data and a master thesis or whatever. In the case of the marine biology example, everything was in Spanish, but the article that came out was in English. But this example is from our own research, where Erik Schultes and Max van der Boom, the authors here, they ran massive computer simulations on the possible variants of the spike protein of SARS-CoV-2, predicting virtual variants of high concern that do not yet exist but are likely to emerge in the near future, enabling Pfizer to make a vaccine against a protein that's not even yet in the nature as far as we know. Anyway, massive CSV files, tabular data, on 3D structure, etc., etc. You feed it to the bot. It starts asking you all kinds of questions. Then it says, are you the author? Correct. Is this your ORCID? Is this your keywords? Is this your abstract? And you get a data explorer. And if you go there, this is online, and you can see it everywhere. If you go to YouTube, here you see the data. This is an article about your data. It's not having any scientific conclusions, just describing the data. You click the FAIR squared button wherever the data are. That's your choice. Could be your own database, your own repository, or your AgBioData one. There is a Jupyter Notebook and croissant type environment. There is a podcast about your data, which is completely automatically generated. And Eric said he could never explain his data and his research better than in that application. And if you click the link button, you can share your data with LinkedIn. This is an incredible tool made by one of the LIFES members, the company Sense Science, part of Frontiers in Lausanne. So this looks like a very complicated slide, but it's almost my last difficult one. We start here on the left-hand side. We believe that publishing, and I'm including databases there, not just articles, when there is a new data, a new article, anything that you could use to increase your curated database, UniProt, whatever. Nowadays, 90% of the data that are supposed to be linked to an article get lost. We say, no, you have to publish an open data article. The European funders already say, hey, that's an article, open access, we can pay for it. So that's what Sense Science does. The data set are somewhere else, but the DOIs or the permalinks are always there. Now your data becomes citable, so you can get credit for your data, not only for your green paper, but for your data. There is a portal where the data are actually made machine actionable. You can place them in a station and make them visitable in the FAIR digital object layer. And that is where we come in the hourglass. We only work on FAIR digital objects. You publish in FAIR Connect. You choose a FAIR implementation profile. And for example, the World Data System with 130 repositories, already a recognized expert community, and say, we will adopt these FAIR implementation profiles. So when an algorithm visits our repository, it knows which ontologies we use, which metadata models, so it can easily operate on the data. Not today, but very soon. So we have a wizard to make FAIR implementation profiles. We can help people. And again, the recommended FAIR implementation profiles, there is a wild growth a little bit now. We want to go down to a few per domain. Could be done by recognized expert communities and finally approved by the International Science Council and CODATA. And for example, your network could make recommended FAIR implementation profiles for your domains and your databases. And then people that publish a new paper could say, the bot could say, would you want to make your data FAIR according to the recommended FAIR implementation profile of AgBioData? Yes, done, with a lot of questions by the bot. So it's made very easy now. And this is not so relevant for you, but we are working very hard in Europe to store all the data outside the reach of your beloved president. So everything is on, companies that don't even have American citizens on payroll because they want to save their data in Europe. But we don't care. People can put the data wherever they want. And the last part of this slide is GoFair is now going around the world. They're also one of the application service providers in LIFES, and they take care of the high quality of FAIR. And here you see all the countries in which we have already offices, and there's more offices coming. That's a very open network. People can just join it. So, unless there are burning questions on the content, let me know with a raised hand. I will say a few more words about the Institute, and then we can have a long time, I hope, for for Q&A. If there are no immediate questions, let me first finish, and then we can ask any question you want. We can go back to slides and so on. So the Leiden Initiative for Fair and Equitable Science was started a year ago, more than a year ago. 10 founding members. They put $1 million in kind and in cash to set it up and find the best legal entity. We decided that it becomes a association that anyone can become a member who qualifies. You have to take FAIR seriously. You have to stay away from vendor lock-in. So there are a number of rules of engagement, but hey, if you don't follow them, why would you want to be a member of LIFES in the first place? The core activity is FAIR implementation guidance for its members, so it helps members, but also by its members, because a lot of the members are actually application and service providers that provide FAIR-related tooling, training, wizards, FAIR verification bots, you name it. Already 30 members before we actually go off. You know, we were formally established only in July. So it's a global association that unites public and private data owners, users, application service providers, and communities to jointly evolve the ecosystem for fair, equitable, and sustainable data reuse for science and innovation. We call that the Internet of Fair Data and Services. As said, we are very much bound to the hourglass model. We don't intervene with the applications and the infrastructure. We just say, whatever you do, we bring you around the table. Literally, we have a nice office. We collectively implement like FAIR implementation profiles, and that's how we innovate. And then you can use that on any software in any repository. We don't care. So all the members have their own backend systems, but they commit to become fully technically, legally, and semantically interoperable via FAIR. As the core goal is now harmonization of new stuff and defragmentation for its members and beyond. Because only in the Netherlands, a small country, you probably don't even know where it is, you know, there is 50 different data sharing initiatives, and some of them are funded with up to 70 million euros, you know, and all of them rebuild something that works, but is not interoperable with the others. And we are defragmenting it by saying, if you have machine actionable instructions in the center, you can send a swarm learning train from Germany to a Visma station in the Netherlands or a Vantage or Link site, as long as you instruct the station with very rich machine actionable metadata. I'm a train from swarm learning. I expect FAIR or OMOP models for the pharma. This is my FAIR implementation profile. So the machine knows for every semantic type which ontologies were used and to expect. So if it sees a UniProt number, it knows exactly where to go. Now, on the website, you will find 2 videos that I recommend you to view. The right-hand one is where I and Robert Dijkgraaf, our ex-Ministry of Science, and now the president of ISC, are explaining why we are setting up LIFES. This was at our kickoff. This is our building. This is the link, very simple, lifes.institute. And we are now in this Poortgebouw, which is very close to Leiden Station, 15 minutes from Schiphol. We have a beautiful room to come together. But in a year from now, we are likely to move to this thing called the Plague House, the Pest House from 1600, which will look very beautifully. And there we will have our offices, hotel, and long stay, and lots of and restaurants, everything there. So people can really come together to work in a very beautiful and inspiring environment. And we already have a mail address that people can claim today to have a pied-à-terre in Leiden, in the Leiden Bioscience Park with 470 companies. And you probably read that Eli Lilly is just coming to us, investing 3 billion in this park, in their new building. So what is LIFES doing? We recognize experimental data, real-world data, and established knowledge. The difference is experimental data are generated with a hypothesis in mind and with a particular experiment. Then real-world data are basically just data that are gathered in a normal process like satellite data or at the bed of a patient, not necessarily with a research purpose in mind, but they can become very important for validation and models and so on, and then they are usually not available. And established knowledge is what we have already published and what is in your kinds of databases. And we have, for example, in health, a graph from 275 databases with more than 5 billion triples that represent everything we know, gene expression, cellular location, and targets, everything. That only works when all of them are made fair by our FAIR workflows. So we make fair digital twins of everything that we want to study. So machines understand them. Digital twins are not enough. You need fair digital twins that are fair digital objects in themselves. And the final goal is that the data are actually reused in an equitable fashion. And here comes the data visiting again, because the pharma can now send an algorithm to the hospital or to a farmer without getting the data, but visiting the data. And an African scientist or Latin American scientist, even if they have low connectivity, they could upload a very small algorithm. They're infinitely smaller than the data. And once that thing is on the internet, it has the same speed to visit all the stations around the world than any other algorithm that is maybe originating from Harvard or from Leiden. So the data visiting is the goal that goes beyond FAIR as such. LIFES really focuses on helping everyone to become a FAIR data station if they own data or database, in the Internet of FAIR data and services, make their data machine actionable, and opening them up under very well restrained conditions, if needed, for visiting by whoever you trust, and only for legal questions. So FAIR, apart from being originally findable, accessible, interoperable, reusable for machines, is now fully AI ready as well. And we say the machine knows what we mean. If that is what you keep in mind from my plea that FAIR is machine actionable, the machine knows what we mean. That's what we need to realize the Internet of FAIR data and services. Here are some links, but that will be in the slide presentation I sent to Marcella, and then you can always go back and view some more videos online. So with that, thank you very much, and it's open for Q&A.